Welcome everyone to the most well-explained Kaggle Titanic solution you will find. Kaggle is an online community of machine learners and data scientists who are willing to share their expertise and datasets while providing a platform for anyone to challenge others in creating solutions for data science-based problems in form of competitions. Titanic is one of these competitions which is recommended for anyone new to the platform. The competition is very simple. Use machine learning to create a model that predicts which passengers survived the unfortunate Titanic shipwreck. When we navigate to the data section in the Titanic competition, we can find the dataset to be used to train this ML prediction. The training set and the test set are the dataset divided into two so that we can use it in the training phase and then the testing phase to get the accuracy. In the training set, we can see that we have 11 attributes to be used in any combination we want to get the best prediction accuracy possible. Now let's get into the hard part. To do the machine learning based coding, our choice was Python language on Kaggle notebooks, but you can use any ML platform you like. For this development, we use several Python packages. Pandas is a software library written for the Python programming language for data manipulation and analysis. When we come to matplotlib, it is a plotting library for the Python programming language itself and its numerical mathematical extension NumPy. Seaborn is a Python data visualization library based on matplotlib. pyplot makes matplotlib package work like MATLAB. Now we have loaded the training dataset and ready to produce the visualization of the survived passengers to get an overview of the survival rate. 1 represents the people who survived. Let's start going deeper into data visualization. When we draw a scatter plot with age against the survived, it shows that the majority of people died were in the age of 20 to 40, but the survived majority is also of the same age range. Thus, it is hard to come up with a strong connectivity between the age and the survived attributes. But when we visualize the data with regards to the gender and survival rate, we can identify that the females had a higher chance of survival. Let's check out a bar graph of the seat classes which were present in the Titanic ship. It's apparent that the many who were in the Titanic were sailing in the third class, while the first class count was slightly higher than the second class. Our next step is try and find a connection between the classes and the ages. We can use a kernel density estimation here. Without a doubt, many who sailed in the third class were young, while the first class ranged up to the age of 60. This shows that the income states of the young should be lower in that era. After that, we can carry out several data description phases to map the embarked port, age, siblings, sex, and the survived passengers in the Titanic wreck. After taking this insight to the data available to us, continuation of the search for patterns and correlations is very important. Therefore, a bar graph comparison of died and survived males and females can be visualized. With that bar graph, it is very clear that the most survival possibility was there for the females. Now, with the knowledge of the survival rate of males and females, let's associate their ages to the comparison. To do this, a histogram is the best methodology. Women have evidently survived more as the histogram shows. A large portion of right side green, The age, when considering the males who survived, seems to be younger. A large set of passengers between the ages of 20 to 40 have deceased. It seems that there is no tight connection between the female survival and the age. But when it comes to males, there is a tight connection between the survival rate and the ages because mainly the young have deceased a lot. Now this is a survival rate against the fare of the ticket. The likeliness of cheaper ticket owners being deceased seems to be high, while the passengers with expensive tickets have survived more. Also, when we take a look at the average of the ages, third class passengers seemed to be a younger crowd, while the first class are in their latter part of life. With this plotting, we have now combined the attributes age, fare, and rate of survival to get the above single chart. The large green dots resemble the higher ticket fares of the adults. Smaller red dots are the adults with lower class tickets. The smaller green dots are the children who survived. Thus, the class correlates with the fare of the tickets. When we use the attribute port of embarkation to check for correlations. Embarkation C seems to have the higher range of ticket fares. We have already established that the passengers with expensive tickets have a higher chance of survival. Okay, that's a lot of visualization and we have found several key correlations to the survival rate. Now let's get into training our model. First, we have to load our datasets to the model. Then the passenger ID should be stored so that we can access the list anytime. Now the preprocessing starts. What is preprocessing? Preprocessing refers to the transformation applied to our data before feeding it to the algorithm. Data preprocessing is a technique that is used to convert the raw data into a clean datasets. In other words, whenever the data is gathered from different sources, it is collected in raw format, which is not feasible for proper analysis due to they containing issues such as loss of data between rows. So for achieving better results from the applied model in machine learning projects, the format of the data has to be in a proper manner. And another aspect is that the dataset should be formatted in such a way that more than one machine learning and deep learning algorithms are executed in one dataset, and best out of them is chosen. This is the exact reason we are doing data preprocessing in our project here, because we will be using this on several deep learning algorithms and machine learning algorithms to find the best out of them to make our model. The attributes fare, age and embarked needs to be cleaned by removing all the null values. For the cabins, we replace all missing cabins with the letter U. We create a new attribute as clean ticket after removing all the punctuations and map the new values under the new attribute name. There are siblings and parents data. What we are going to do is to create three new sets from those data as family single, family small and family large according to the number of people in the family. The attributes we will be using are the source, survived, age, fare, embarked, cabin, family, family single, family small, family large, class, sex, title, and finally the ticket. Now we have almost finished cleaning the dataset, but we still have to one hot encode several attributes such as embarked, cabin, sex, etc. Encoding is to or one hot encoding is to convert this kind of categorical text data into model understandable numerical data. Now the data cleansing is complete. The next step is to split the full dataset we have already cleaned into training and testing datasets. Standardization or normalization is the process of rescaling one or more attributes so that they have a mean value of 0 and a standard deviation of 1. Standardization assumes that your data has a Gaussian distribution or a bell curve. This is so that no overfitting or underfitting takes place in your dataset. Here we use the sklearn package to import several models such as gradient boosting classifier, decision tree classifier, random forest classifier, SVC, ADA boost, logistic regression, linear discriminant analysis, k-neighbors, Gaussian NB, and quadratic discriminant analysis. Altogether, 10 classifiers as the model selection step. Here we stumbled upon some value errors as you can see. This has happened due to a few spelling mistakes we have done. The correction steps are also included because you might also be stuck in the same position as we are. Finally, we got a table with the x and y axes as accuracy and the classifier. And XGB boost classifier or gradient boosting seem to be having the highest accuracy. Then we load the testing and training data into NumPy arrays so as to send through k-folds validation. This technique involves randomly dividing the dataset into k groups or folds of approximately equal sizes. The first fold is kept for testing, and then the model is trained on k-1 folds. In our case, the number of folds is 10. Now, we train our model using all 10 classifiers so that we can find and select the most accurate model. As the XGB classifier shows the highest promise, we use that model and check for the training accuracy. It turns out to be 0.84. As we did the coding in Kaggle notebooks, we can commit the edits and export the results as a CSV file. Finally, we have completed the training, and now we have to test and see how accurate our model is by uploading to the Kaggle competition. We have to navigate to the Submit Predictions tab and upload the exported CSV results file and make the submission. That's it. We have solved the Kaggle competition Titanic. If you browse through the leaderboard, you will see that there are some with the accuracy of 1 or full accuracy. This never happens in an ML model. They have edited the resulting CSV file to get this result, which falls under cheating. Therefore, do not worry for never being able to achieve an accuracy level of 1 in any competition. Your target should be to achieve a value extremely closer to 1, and then you can submit it to the Kaggle competitions.